And today we are going to discuss about the motion of a car along a leveled road. That is when a car moves along a curved level road, and in the case of a banked road. So let us see the difference. What difference does it make on the maximum speed with which a car can negotiate a curved path? And how does the frictional force support in this case in the two different cases, and what is the expression for the maximum speed of the car with which a car can negotiate or describe a circular path. So first let us see motion of a car along a level road. So I have shown a curved path in which a car is trying to describe a circular path of radius r. Say suppose the circular path has a radius r, and the weight, what are the different forces acting on the car? The first force is the weight itself, which is acting vertically downward. So W is equal to mg. What is the other force which can happen at this time? It is the normal force or the normal reaction, which is happening perpendicular to the surface of the road, which I have shown it as N, which is vertically upward. And you can also see Fs or F, the frictional force, which tries to keep the car in circular motion. So it always acts along the surface, and it is between the tires and the surface of the road. So it is shown towards the in the horizontal direction towards the inner direction or in the horizontal direction. Okay, so these are the forces acting on the car. Now what we have to do is we have to convert this diagram into a free body diagram, where we can see the car. Instead of the car, I have shown it as a point and the different forces acting on it. So let us see the free body diagram. A free body diagram is a diagram where you represent rather graphically the different forces acting on a body. So the body is shown as a point object here, and the different forces are shown in different direction. The length of the vector will show you the what do you call the magnitude of the vector. So here this is the car. This dot is represented by the car, and the weight W, which is acting downward, and the normal force, which is acting upward, and the frictional force, which is acting in the horizontal direction. Now in order to calculate the maximum speed with which this car can move along the circular path, we have to separately consider the forces acting along the different directions. So, in order to find out the different forces along happening along the vertical direction, let us see N and W are the forces acting along the vertical direction, and we know that there is no acceleration along the vertical direction. How is the car moving? Car is moving along the horizontal direction, so there is no acceleration which is happening along the vertical direction. So we can say that N will be balanced by W, or we can equate N is equal to W or N is equal to mg. So we don't have to consider along any forces, or as there is no acceleration along the vertical direction, we can simply write this expression N is equal to mg. Okay, now next is what we have to consider is the horizontal direction. Along the horizontal direction is the actual acceleration taking place, which is the centripetal acceleration, because this can be considered as a body moving in circular motion. So for any object to be in circular motion, it has to be provided or necessarily been supported by a force which is known as the centripetal force, and the acceleration associated with this body is known as the centripetal acceleration. Now in this case, the frictional force is the only force acting along the horizontal direction, so that frictional force is supposed to be providing the necessary centripetal force which keeps the body in circular path. Okay, so let us see what is the frictional force here, F, or you can also write it as Fs. So we can write Fs. We know the condition, frictional force, the maximum value of frictional force is known as the limiting friction, and it can be less than or equal to mu Sn. The force of friction. So in this case, we always, as we have to find out the maximum speed, we always go with the maximum velocity, maximum frictional force. So we have considered the static friction and let us write it as Fs less than or equal to mu Sn. So as we are concerned with the maximum speed with which the car has can move around a circular path, let us try to equate it with the maximum or the limiting friction. So let us write it as Fs is equal to mu Sn into n. Now we know that n is equal to ng according to this equation, above the above equation. Now this is actually the frictional force provides the necessary centripetal force. So we can write this will be equal to mv square by r, where m is the. So let us write mu s into mg is equal to mv square by r. M gets cancelled, and what you get as an expression for v square is this. Let us write it as v square max, because we are interested in the maximum speed, is equal to mu s into r into g, mu s into r into g, or V max is equal to root of mu s into r into g. So this is the expression for the maximum speed with which a car can move around a circular path, which is a leveled road of radius r, and mu s is the coefficient of static friction, and this is the expression for the maximum speed with which the car can move around a circular path. So we can see that the maximum speed depends upon the coefficient of static friction, which is a constant for a pair of surfaces, and it is also directly proportional to the square root of r, which is the radius of the circle. So let us find out or figure out if we can make any change in this maximum speed when there is any alterations, or when we can modify the engineering of the, we can do something with the engineering of the road.